You know, what better way to start a Thursday than solving trig? So yesterday we did solving trig, where it was right off the unit circle and you could just find it, correct? Then we did solving trig where it wasn't right off the unit circle and we had to do the 3 steps. One was find give by itself, then find the reference angle, cast rule to get the arms, get your angles, right? These are the 3 steps. So we're going to use those today. But what we're going to start with is something that isn't in like cos of theta equals 0.8080. We're going to have to get it there. Okay? Literally that's it. But we're gonna do it together. Teamwork. Page 211. We're doing number 5. A. 3 cos theta minus 1 equals 4 cos theta. And we want it from 0 to 2 pi. If you notice, 2 pi is not included, right? So if the answer 2 pi came up, I wouldn't be allowed to use it because it's not included, it's just less than it. Okay? And if you can see over here, it's the 22nd. I don't know why that popped up. And it's 9:07, 43 seconds. I don't know how to get it to go away. I think I tapped that. Okay, great. All right. So our goal before we do the 3 steps is we have to have it equal to trig ratio equals answer, correct? So what can I do right now? I have a single trig and a single trig. Think of the trigs like they're x's. So I could do this if this makes it easier for you. You can go let x equals cos theta. And then I can go 3x minus 1 equals 4x. Now you solve for x, right? What could I do? Add the 1 over and we should get our x's together. Okay. So what are we going to do first? I really hope this is just silent because you know what you're doing, not silent because you don't. How do I get my x's together? How do I move the 3x? Yep. You subtracted. Okay, it was silent because you. Now, if you don't do this, if you don't do a let statement, you can't just randomly throw x's in. Okay? You have to go let x equal cos theta so that we know what the heck x is. You can't just randomly be like, ah, they're x's now. Okay? So we subtract 3x. We're going to get negative 1 equals x. Now, once we have x by itself, we can actually go cos theta equals negative 1. Right? We can bring the cos theta back. Or you could never make cos theta go away and you can combine them. But often people, if they switch them with x's, they can solve it a lot easier. So, recycling? Okay. So we need where cos theta or x equals negative 1. Go to your unit circle. Remember unit circle's bestie. You didn't even think to trade without it. I would say I can use your best friend. The unit circle. Where is cos equal to negative 1? Where is x equal to negative 1? At pi, right? So theta equals pi. Some people will say 2 pi, but at 2 pi, it's actually what? Positive 1, correct? And I wouldn't be able to include 2 pi. So had this actually been cos theta equals positive 1, my only answer would be 0. Because my answer should be 0 and 2 pi, but I can't include 2 pi because it's not equal to it. Okay, this is it. So my answer is theta equals pi. E. Root 3 tan theta plus 1 equals 0. And the domain is negative pi is less than theta is less than or equal to 2 pi. Negative pi is less than theta is less than. Yep. Oh, I whispered. mic isn't on. Thank you for reminding me about the mic. That is swell. So excited. Oh, I'm doing so good. I solidly did not miss that mic since September, and then now 2 days in a row. When I do something, I do it well, which is also includes not plugging that mic in. Yeah. Okay. Okay, so we have to get tan theta by itself. So what are we going to do? What we could do is what? Right? We get over to the other side. We could go, if this is easier for you, let x equal tan theta, and then go root 3 x plus 1 equals 0, and then you solve it like a linear. So we subtract 1, root 3 times x equals -1, and then I have to divide by root 3. The problem with this is people will box it and say they're done. This is the problem with replacing tan theta with x, because you're so used to getting x equals answers, you box it like that, and you're like, good, I'm done. You're not done. X wasn't even part of this question. You made it part of this question. So you should not box that. It should be now tan theta equals -1 over root 3. Okay. So this one, if you don't know, tans and cotans can pop up as root 3s, or -1 over root 3s, or root 3 over 3. They're actually off the unit circle. But if you don't spot that this is off the unit circle, what we can do is we can say, hey, I'm going to do the 3 steps. Step 1, reference theta. I'm going to get my reference angle, which I'm going to do tan -1 of 1 divided by root 3. Why did I not do negative, even though the trig ratio is negative? Why did I not do negative? Because reference angles you always do positive, right? So it ends in the first quadrant, right? Every single time you do positive. Now, I would do this in degree mode each time. The reason why I always do these in degree mode is because sometimes they're nice exact values of a radian, but they're never going to come out as an exact value because they're going to have the pi in them. Yeah. I'm just typing it in, so it doesn't matter. Yeah. So if you go tan 1 divided by root 3 in degree mode, what do you get? 30, right? If you did it in radian mode, you're going to get pi divided by 6 in decimal form. I don't know what that is, and I'm not going to recognize it. Okay? So I always do them in degree mode just to see if it comes out nice. So in this case, it came out as a 30 degrees, which is pi over 6. Right? Or I could say 30 degrees. It doesn't matter, as long as my answer in the end is in radians, right? Step 2, casserole. This is tan theta equals -1 over root 3. For the casserole, all I care about is the sign and the trig ratio. So I need tan negative. Where's tan negative? In S and C. So it's here and here. Right? And I know my boom, 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 boom. This is pi over 6 or 30. So this angle here is 180 minus 30. Which is 150. This one is 360 minus 30, which is 330. Now, sometimes it's easier to do in degree mode because when you have restricted domain, that's weird. So this one is going to be from 180 degrees to negative 180, sorry, to 360, technically, correct? So do both of those fit? 150 and 330, do they fit between negative 180 and 360? Yeah, because 0 to 360 is inclusive. But do any of them possibly fit negative as well? Let's check our coterminals. So we're going to do 330 minus 360, and I get negative 30. Does that fit? Yeah. What about the other one? 150 minus 360 equals negative 210. Did that fit? No, it's too big, right? So I actually have three solutions for this one. Theta equals negative 30, 150, 330, which is lovely, except my question was in what mode? Radians. So what do I have to do to turn these into radians? Degrees to radians is really easy. Divide by 180, add a pi. Right? Remember we did it in a whole unit circle. Just divide by 180 and add a pi. So 30 divided by 180 reduces to 1 over 6. So I'm going to get negative pi over 6. 150 divided by 180 gives me 5 pi over 6. I'm going to add the pi. And then 330 divided by 180, I'm going to get 11 over 6 is what it reduces to, so 11 pi. Because remember, degrees to radians pi on top, so I multiply by pi divided by 180. So if I'm just doing exact pi, we can just divide by 180 out. Right? So degrees to radians is the easiest. So do I have to radian measure it? No. Could I have? Yeah, I could have went pi minus pi over 6, got 5 pi over 6. 2 pi minus pi over 6, got 11 pi over 6. I could have totally used pi. Okay. C. Root 2 sine x minus 1 equals 0. And my restricted domain is between negative 360 and 360. C, and then D is 3 sine x minus 5 equals 5 sine x minus 4. From negative 360 to 180, not inclusive. We're going to try those two. So for the sine x1, we could go let x equal sine x. I don't want to do x, it already has an x. I'm going to go let n equal sine x. So root 2 m minus 1 equals 0, add the 1, root 2m equals 1, divide by root 2, and equals 1 over root 2, which is actually the same as root 2 over 2, right? So I have sine x equals root 2 over 2. On the unit circle, that happens at x equals here and here. So 45 and 135. And then I have to check my coterminals, right? I'm going to subtract 360 from each of them. So I'm going to get x equals 135 minus 360 equals negative 225. Does that fit? Yeah, because it's from negative 360 to 0, 0 to 360. And then 45 minus 360 equals negative 315. And then x equals 45. 135, negative 225, negative 315. Okay. This one, I'm going to make n equal sine x. So I'm going to get 3m minus 5 equals 5m minus 4. When there's two m's, I just move one of them. So I'm going to subtract the 3m. So I'm going to get negative 5 equals 2m minus 4. Then I'm going to add 4. Negative 1 equals 2m. Divide by 2. M equals negative a half, which is sine x equals negative a half. Sine x equals negative a half at the 30s, right? So 210 and 330. Do either of those fit in the domain? The domain is from 0 to 180. Value is fit? No. Let's check from 0 to negative 360. It's coterminals and see. So I'm going to subtract 360 and I'm going to get negative 150. Does that fit? Yeah. And subtract 360 and get negative 30. Does that fit? Yes. So x equals negative 150 and negative 30. Make sure, you guys, that you use the variable that it actually has, right? So if it's using x, make sure you have x equals. Okay, I'm using theta, make sure you have theta equals that. Okay? E and F. I'm going to write down, and then we're going to move on to degree 2. So E is 3 cotan x plus 1. So remember, when you get cotan, you can just flip it down and get tan, right? When you get cotan, you can flip it down and get tan. Flip answers, not angles. So 3 cotan x plus 1 equals 2 plus 4 cotan x. And the restricted domain is negative 180, less than or equal, not less than or equal to, just less than, x less than 360. That's E. And then F is root 3 secant theta plus 2 equals 0. Negative pi is less than or equal to 0, or sorry, theta less than or equal to 3 pi. So for this one, I'm going to go at m equal cotan x. I'm going to get 3m plus 1 equals 2 plus 4m. Subtract my 3m. 1 equals 2 plus m. Subtract 1, add the 2. M equals negative 1. So cotan equals negative 1 over 1, technically, right? And then I immediately go, no thanks, tan x equals negative 1. Okay? Now you could have done your trig ratios and found what happens at 45. By doing the 3 steps, right? You go tan negative 1. Sorry, to reference data equal tan negative 1 of a positive 1, and they'll get you 45. Why do the 1s and negative 1s happen at 45 for cotan and tan?
Because if the numerator and the denominator are equal.
Yes, exactly. So the numerator and denominator, we're dividing coast by sine and sine by coast, right? Or x by y, y by x. And at 45, the x and y are the same number. So when you divide them out, you're going to get positive 1 or negative 1, right? So you can do this, or you say tan is negative here and here. So it's going to be 45 here and here. So it's going to be 315, 135, both of which fit. And then we have to check 135 minus 360 is negative 225, which is too big. 315 minus 360 is negative 45, which is good. I'm going to do thetas, it's x's. Come on, so x equals negative 45, 135, and 315. This one's a secant. So that's m equals secant theta. So I get root 3m plus 2 equals 0. root 3m equals negative 2, divide by root 3, m equals negative 2 over root 3. M happens to be secant. And when I get secant, what can I do? Flip my answer and get cos, right? So cos theta equals negative root 3 over 2. Cos equals negative root 3 over 2 here and here. Which if I want to do in degrees, I can. It'd be 150, 210. Which both fit. So this is negative 180 to, is this 540? 360 plus 180, 540, I think. Okay. So we're going to try out their coterminals and see what they get. So 150 plus 360 equals 510, which fits. 210 plus 360 equals 570, which does not. And we check their coterminals the other way. 150 minus 360 equals negative 210, doesn't fit. And then 210 minus 360 equals negative 150, which does fit, right? So my thetas are going to be 150, 210, because those fit. And then their coterminals of 510 and negative 150. And I'm done, right? No, I just boxed that, and sadly they're like, you really royally did bad things. Because my domain is in radians, my answer needs to be in radians. So 150 is 5 pi over 6, 210 is 7 pi over 6, 510 is in here over 6, what's 510? What is it reduced to? Anyone? 510 divided by 180, how did you get it? And negative 5 pi over 6. Okay. Then what happens if we have degree 2 trig functions? So these have all been linear trigs, right? We're going to do degree 2 trig. So we're going to look at number 7. A. 2 cos squared theta minus 3 cos theta plus 1 equals 0 in the restricted domain of 0 and 2 pi. So our first thing we can do is not overwhelm ourselves and make cos theta equal to m, right? Let m equal cos theta. So I'm going to go 2m squared minus 3m plus 1 equals 0. Now we're back to grade 11. Grade 10 factoring, grade 11 solving, right? So we say what times what equals 2, what plus what equals negative 3. Negative 2 and negative 1. And I have to decomp because I don't have a 1 in front of my m squared, right? So I have to replace negative 3m with negative 2m plus negative 1m. So I'm going to get not an equal sign here. There's already an equal sign running down there. I'm going to go 2m squared minus 2m minus 1m plus 1 equals 0. And I group the plus sign of the thing. Take out a 2m, and I'm left with m minus 1. Take out a negative 1, and I'm left with m minus 1. So I get 2m minus 1 equals 0. M minus 1 equals 0. I have to solve them out. Here I'm going to add 1. 2m equals 1. m equals a half. This one's m equals 1. And then people box it and move on. I like using m's because usually people won't box an m. They'll be like, what the heck is an m doing? An x, you guys box, you're like, golden, x equals, I've taught them my whole life, right? But m's, you might think like, what's up? So I let cos theta equal m, so I'm going to go cos theta equals a half, and cos theta equals 1. So once you actually do the part of grade 11, solving, you literally just have 2 linear trigs instead of 1. We've just been doing linear trigs, right? You now just happen to have 2 that you have to answer. So it's twice the fun, really. So we need between 0 and 2 pi. Where is cos equal to a half? Between 0 and 2 pi. I'll get a half. Pi over 3 and 5 pi over 3. So those are our 2 solutions for here. And then where is cos theta equal to 1? Where x is equal to 1, which is here, right? Which is at 0. Well, I'm putting a bracket. Which is at 0 and 2 pi. We agree? What's my catch? It can't be 2 pi. So it's just going to be theta equals 0. And so when I write my answer in the end, I'm going to go theta equals 0, pi over 3, and 5 pi over 3. So the only catch is if I get a cosecant or a secant or a cotan, and you take whatever I have as a fraction, flip it, and make it one of my primary trig ratios, right? I can pull it right off my unit circle, I go ahead. If I can't, I have to do the 3 steps. Reference angle, cast rule, get answer. So your homework is page 212, 7B, C, and D.